All right, in 3.4a, we're going to start our discussion on the fundamental theorem of algebra. Here's what it says. It says if f of x is a polynomial of degree n, remember that's the highest power, where n is greater than 0, then f has at least one 0 in the complex number system. Now, the complex number system has two parts. They could be real or imaginary. Okay? So they can have imaginary zeros or real zeros. Okay? That's what complex number system means. So then we use the linear factorization theorem, where x is a polynomial of degree n, where n is greater than 0. Then f has precisely n linear factors, and we can write them this way. You know, x plus whatever, x minus whatever. Write all of our zeros as factors. Okay? And that's what we're going to do in this lesson, is factor things down all the way down to a linear factorization, find all the roots, real and imaginary, and then write them as factors. That's bottom line what's going to happen. So let's try this. So it says find all the zeros of the function. Is there a relationship between the number of real zeros and the number of x-intercepts on the graph? All right, so the way you're going to begin this is use your calculator, okay? And I want you to put your equation in the y equals, okay? Put the equation in the y equals, which this first one is right there, and I go to graph it. Now look at it, okay? Look, it crosses the x-axis right here, all right? And what is that value? 1, 2, 3, 4. So it crosses where x is 4. So what does that tell me? That tells me that there is a root there at x is 4. So I'm going to sketch that graph on my paper, just so I know where I started, where x is 4. So I'm going to use that 4 as my first root, and I'm going to do synthetic division. 1, -4, 1, -4. 1 times 4 is 4. -4 and 4 is 0. 0, 1, 4, 0. Okay, so that's clearly a root. And then this is just x squared plus 1 equals 0. X squared equals -1. So we take the square root. Then we know x is plus or minus I. All right, so then what are my zeros? Well, the 4, -I, and plus I. Okay, so then it says to write as a, need to write it as a linear, linear factorization. So the way I would do this is I would say f of x equals, make the 4 a factor, so x minus 4, and then put i's in factors, x minus I, x plus I. All right, and then the question says, is there a relationship between the number of real zeros and the number of x-intercepts? Well, I have one real zero, and I only had one x-intercept. All right, so that's our relationship. Now, remember the power right here is a 3. That means I should have 3 zeros. I have 1, 2, 3 zeros. We got it. Now let's try this again. Let's look at example 2 on the graph. So when I graph example 2, look at it right here. It doesn't cross the x-axis at all, okay? So what does that tell us? Well, it's like way up here. It doesn't cross the x-axis, so that means I have no real roots, okay? No real roots. Or no real zeros, if you want to call them zeros, that's fine too. Now, I still got to figure this out, so I can try factoring. And this one will factor x squared plus 2 times x squared plus 2. X squared equals -2. X squared equals -2. So take the square root. I get x equals plus or minus I square roots of 2. X equals plus or minus I square roots of 2. All right, so this is a double root, right? These are doubles. So I have my factors then would look like this. I would say x plus I square roots of 2 squared, there's 2 of those, and x minus I square roots of 2. And there's 2 of those because I have a negative I squared root of 2 here and negative I squared 2 on the right. Okay? So they're both double roots. There's my factorization. Now let's think. There are no x-intercepts and I have 4 imaginary roots. Okay, and I should have 4 roots because the power is 4 on the equation. So connect it to the graph. It doesn't cross the x-axis. That means all 4 roots have to be imaginary. All right, let's try example 3. We're going to find the zeros of the function. We're going to write our polynomial as a product of linear factors, and then use that factorization to determine the x-intercepts of our graph, okay? So I am going to graph this just to kind of see where we go. Okay, if I zoom out, look, it's doing this business right here, okay? Now, if I want to, I can go to my table and see if I can figure out what are these values right here where it's crossing the x-axis. So if I go back to my regular screen, I can try to count, but it doesn't look like it's perfectly exact. So I'm going to go second table and look at, okay, where is the y0? So my y values are getting smaller. And look, my y went from positive to negative right here. So I know that there's an x somewhere between 5 and 5.5, but it's not a perfect number. It's not a perfectly round number. And then if I look at my y values, they're negative, negative, negative. Then they jump to positive. So then there's another x value, x root, between 8.5 and 9. Now, that's not going to be good enough for what we're doing, but that gives us an idea. We do know that it crosses the x-axis. We just don't know where. So we've got to continue our process of finding this. So if I sketch what we saw something like this, right? It crossed the y-axis way up here where y was 46. And we got to find those too. So looking at this, we know all sorts of ways to solve this. You could complete the square on this one. You could do quadratic method. Whatever way you wanted to do it would work. Let's do quadratic method. So let's do 14 plus or minus the square root of 14 squared is 289 minus 4 times a over 2 times 1. So let's clean this up a little bit. So 289 minus all of this gives me 12. Okay, I can clean up that radical. 12 factors down to 2 square roots of 3. 2, and now I can reduce every term by 2. So that's going to be a 7, that's going to be 1, and then that's going to be a 1. So what I have is that x is 7 plus or minus square roots of 3. So then to write these as factors, as factorization, I would say, all right, so notice the negative with the 7 because it was positive originally, and then the plus version of the square root of 3 and the negative, okay? Now, if you wanted to, so if you wanted to type this part of the, if you wanted to figure out that 7 plus the square root of 3 in the calculator, you would get like 8.73, sorry. We knew it was somewhere between 8.5 and 9. If I take 7 minus the square root of 3, I get like 5.29, which makes sense in where we were looking at the table. Okay, so here's our factorization. So what do we have? These are 2 x-intercepts, and they are real. They are real numbers. So I have 2 x-intercepts and 2 real roots. Okay, should make some sense. All right, so there's all part of your answer here. You don't have to do this last part, but I do want you to show me the factorization. All right, let's try it number 4. All right, so when we look at this graph, we can use that table to help us find out what zeros are there if they're real numbers. So I noticed that it's crossing the x-axis where x's are positive. So I'm going to scroll around until I find, look at that, where x is 1.5, y is 0. So 1.5 is 3/2. So I'm going to start there. Use that x-intercept to help me do synthetic division. So doing that, knowing that this is 3/2, we're going to 2, negative 3, 8, negative 12. Okay, don't be afraid of the fraction. Bring that 2 down. Well, 2 times 3/2 is 3. Bam. Negative 3 and 0, that's 0. 0 times that is this. 8, okay. 8 times 3/2 is what? 24 over 2, which is 12. And there it is. Okay, so now I have 2x squared plus 8 equals 0. Well, I can factor out a 2. x squared plus 4 equals 0. So I can throw the 2 out. There's no x attached. So x squared equals negative 4. Take the square root of both sides. So x is plus or minus 2i. All right, so when I write these, my roots are 3 halves, positive 2i, and negative 2i. Then to write it as a factorization, I'm going to do x minus 3 halves, x minus 2i, and x plus 2i. And there it is. There's my factorization. Okay, we've got a couple more examples. Working through this very tediously, I get that. So let's look at example 5 in the calc. All right, so here's number 5 graphed for us. So look at that. It does cross the x-axis real nicely. And let's go to the table to see if we can find where that place is. So go to our table, and I'm going to look at where is, we knew it was negative, somewhere negative, so I'm going to go down. Where is that y value 0? Right there, where x is negative 3. So I'm going to start with a negative 3 to test it, okay? So I'm going to sketch that graph, and this right here is negative 3. So that gives me a place to start with good old synthetic division. So I'm going to do 1, negative 7, negative 1, and 87. And I'm going to divide by, so drop the 1 down. 1 times negative 3 is negative 3. Negative 10. Negative 10 to negative 3 is 30. 30 minus 1 is 29. 29 times negative 3 is a lovely negative 87. So that came out real nice and neat. Now, this is going to be x squared minus 10 plus 29. That does not factor, but we can do quadratic method real quick. So we'll have 10 plus or minus the square root of 100 times minus 4 times a times c over 2a. So that's 10 plus or minus negative 16. So that cleans up to 10 plus or minus 4i over 2, and that will simplify to divide everything, each part by 2, so I get 5 plus or minus 2i. So then my zeros are x equals negative 3, 5 plus 2i, and 5 minus 2i. So then I write them as factors. Write the equation as a factorization, so I'll go x plus 2/3. I'm sorry, x plus negative x plus 3. Now be careful with these guys, okay? These guys work together, so you go x minus 5 plus 2i, and then x minus 5 minus 2i. It's a little tricky, feels a little redundant, but that's really your answer. So you have one x-intercept, and that is reflected in your factorization. You have 2 imaginaries and 1 real. All right, let's try number 6 real quick. Let's graph this and see how it comes out. There it is. Okay, so you can see what's happening here. It does this little zigzag thing, and let's see on the table, where are those roots? Where is the y 0? Okay, look right there at negative 2, the y is 0, and so it's doing this. So we know this guy right over here is negative 2, and we need to know what that point is over here, and we know x is positive, so we're going to look at our table in the positive x's and see what can we find. Okay, it's right there where x is 1. There's our other root. Okay, so, and this is important that you catch this. Notice how the graph is bouncing off the x-axis. This is a double. And that's going to be important. We're going to use that when we do our synthetic. So here's a single negative 2 and one with a double multiplicity. So let's start with our negative 2 and let's do synthetic division. Let's do 1, 0 because I need a 0x fourth. 1, 2, negative 12, and 8. Bring it down. 1 times negative 2 is negative 2. 2 times negative 2 is 4. This is 5. Negative 10. Negative 8. This is positive 16. So that gives me 4, negative 8, and 0. All right. Now now let's use what's left. Let's use the root of 1. Do this. So bring the 1 down. 1 times 1 is 1. Negative 1 times 1 is negative 1. 4 times 1 is 4. Negative 4 times 1 is negative 4. Again, it's 0. Okay, now this is where you get to use the double. You get to use the 1 twice. Okay, because the graph says it's double, we get to use it twice. Bring that 1 down. 1 times 1 is 1. This is 0. 4 plus 0 is 1. And 0. So what have we done? This was x to the 5th. This is x to the 4th. This is x to the 3rd. This is x squared. So now I have x squared plus 4 equals 0. So that means x squared equals negative 4. So x is equal to plus or minus 2i. All right? Now, what are our zeros? We know our zeros are negative 2. And we know that x is 1, and that's a double root. And then we have x is positive 2i, and x is negative 2i. Okay? So to write this as factorization, I'm going to try to squeeze this in really small. I'm going to do x plus 2, x minus 1, 2 times because it's a double. And then I do x minus 2i and x plus 2i. Okay? So there it is as a factorization of the whole. All right, so I'm giving you a lot of examples, a lot to think about, and we're going to practice this in class. Please let me know what questions you have. It is a work in progress, so do your best, and we'll talk about it in class tomorrow.